Good evening to all of you and welcome to our sister's chemistry lecture. Today we are going to see the continuation of basic concepts of organic chemistry. Last time we talked about inductive effect, we talked about resonance, and we talked about electromagnetic. Today, our lecture, we are going to talk about very important point. That point over here is hyperconjugation. What is hyperconjugation? Let me explain. Normally, when carbon and hydrogen, whenever we have when carbon, hydrogen, sigma electrons are in conjugation to a pi, this conjugation is known as sigma, that is carbon hydrogen, pi conjugation. See, what are the requirements? First thing, we require a carbon hydrogen sigma bonds. Conjugation meaning is near to it, is they are neighbor to each other. They are neighbor to each other. So carbon hydrogen bond is neighbor to what? It is neighbor to a pi bond. Then something will happen. I cannot explain you what does mean by hyperconjugation, but it is also known as excessive conjugation or hyperconjugation. The meaning of hyper is excessive. We use this word. Sometimes someone is very active, we call it he is hyperactive. Hyper means excess. The excess conjugation. However, before I explain you what is hyperconjugation, before we understand what is hyperconjugation, what are the requirements for hyperconjugation? Let us understand that there are three requirements. We should have at least one compound which should have at least one sp2 hybrid carbon. We should have a compound which has sp2 hybrid carbon, because when there is sp2 hybridization there has to be a pi bond. We require one pi bond, either alkene, then we require alkyl carbocation or alkyl free radical. Till now, I have not taught you, we have not learnt about alkyl free radical or alkyl carbocation, but we are going to talk about it in today's lecture itself. So, first, right now we will learn about only this part. That says, first thing we should have at least one sp2 hybrid carbon. That means हमारे पास डबल बॉन्ड पाई बॉन्ड होना जरूरी है. First requirement. What is the second requirement? Here, phone says a carbon. Actually, it's alpha. What happens sometimes certain phones changes alpha into it. तो यहाँ पे है क्या? Alpha carbon with respect to sp2 hybrid carbon should have at least one hydrogen. Let me explain you both of them. If both these conditions are fulfilled, then hyperconjugation will take place in the molecule. Let me explain both the conditions in detail. See, we should have at least one carbon which has double bond or sp2 hybridization, and we should have one alpha carbon. What does mean by alpha carbon? See here, this is a sp2 hybridized carbon. This is also in sp2 hybridization, because both of them, they are going through double bond. They are having double bond with each other. Okay. The carbon next to double bond, it's known as alpha carbon. Let me explain the way. Suppose we have a double bond like this. I'm sorry, the valence was not touching. Now valence is fine. Here, CH, CH2, CH2, CH3. This is sp2 hybridized carbon. The next carbon to sp2 hybridized carbon is known as alpha. Next to that is known as beta, and next to that is known as gamma. Okay, alpha, beta, gamma. In Greek letters, they talk about number 1, number 2, and number 3. So number one carbon adjacent to sp2 hybridized is known as alpha. Number 2 adjacent to sp2, 1 and 2 is known as beta, and number 3 is known as gamma carbon. First requirement says we should have one sp2 hybridized carbon, which we do have. It should have one alpha carbon, that means it should have one nearby carbon. Not only one alpha carbon, it should have at least one hydrogen. Alpha carbon should have at least one. Here we got 3. We require at least 1. We require at least 1. Here alpha carbon also has 2 hydrogen. The hydrogen on alpha carbon are known as alpha hydrogen. Is there any doubt over here? Any questions? If you have not understood anything, ask me. If you have not understood any point, first of all, what is sp2 hybridized carbon? You know, when they make a double bond, it's sp2 hybridized carbon. The carbon adjacent to sp2 is known as alpha carbon. It should have at least one hydrogen. Okay, the hydrogen on alpha carbon are known as alpha hydrogen. Okay, now I have one compound which is in double bond. This is alpha carbon. However, this alpha carbon, it doesn't have any alpha hydrogen. We had 3 structures. We had how many structures? Structure number 1 here, structure number 2, and structure number 3. Structure number 1 has sp2 carbon as well as alpha carbon, alpha hydrogen. Structure number 2 had sp2 carbon, had alpha carbon as well as alpha hydrogen. Structure number 3 has sp2 carbon, it has alpha carbon, but it doesn't have, actually it doesn't have absence of alpha hydrogen. Since there is an absence of alpha hydrogen, this structure number 3 will not show hyperconjugation. It will not show you hyperconjugation. These two will show. This will show hyperconjugation, this one will show hyperconjugation. But this one will not show. Why it will not show? Because of these requirements. Requirement says a compound should have one sp2 carbon. Okay, we have stopped here. Other 2 requirements, we are going to talk about these 2 afterwards. And alpha carbon with respect to sp2, and that carbon should have at least one hydrogen. If these conditions are fulfilled, then hyperconjugation will take place. Otherwise not. What is hyperconjugation? I have not taught you yet. I have not taught you what is hyperconjugation. I have taught you what are the requirements for hyperconjugation. Is that fine? What is hyperconjugation? We are going to see. Here, this compound will show hyperconjugation because it has alpha carbon, alpha hydrogens. This compound, is not properly drawn, but I had already explained you. This compound also I had explained you, so no issues. But what is hyperconjugation? Let's see. Okay. Before we understand this definition, before I explain you this definition, let me explain you in detail what is hyperconjugation with an example. Let me explain it with an example. Here, can you see over here? This is sp2 hybridized carbon. Correct or not? It has an alpha carbon. It has 3 alpha hydrogens. Is that understood? It has 3 alpha hydrogens. Now, hyperconjugation, it takes place in the presence of certain reagent. I am not going to, in today's lecture, it is out of our scope to explain you what are those conditions where hyperconjugation takes place. We are not going to study about the conditions where hyperconjugation takes place. But what is hyperconjugation, that I am going to explain. But what is hyperconjugation? Why it takes place? Where it takes place? That is out of our semester 1 syllabus. Suppose due to certain chemical reaction conditions, this double bond sits over here. This double bond sits over here. Then we get, okay, here it gets an extra electron. What has happened? Let me explain you again. This double bond has shifted over here. That means the bond which was present between the carbon number 1 and carbon number 2, which was equally shaped between carbon 1 and 2, now it is shifted to carbon number 1. Now it is shifted to carbon number 1. It is delocalization of electron. Electrons are shifting to where? Carbon 1. Earlier when we had seen inductive effect was like this. When one group pulls electron towards itself, second carbon also feels that pulling throughout the carbon chain. But in that carbon chain, okay, electrons never left its orbital. It was only pulled towards more electronegative substance or element, rather say. It was pulled. It has never left its own orbital. But here there is something else is taking place. Here electron is being shifted. We call it delocalization. And because of that, this carbon will gain extra electrons, so it will develop negative charge. The next carbon, thank you. God bless you. I'm recording this carbon, it has lost its electron to the adjacent carbon. They were sharing one electron. I think I have written too many things over here. Let me just erase. What has happened over here? Carbon number 2 has given away its electron pair to carbon number 1. Is that fine? Is that understood? Now, because of that, alpha carbon, here in the case of carbon number 3, which has 3 alpha hydrogens, which is 3 alpha hydrogen. One of them will give its electron pair to between these two carbons. One of the hydrogen will give electron pair between these two carbon atoms. Okay. And what are you going to get? Okay, let me erase all this and see this is what will happen. This carbon has received the electron pair, so negative charge. Here earlier there was a double bond. Now the double bond has gone, and one bond from this hydrogen has come over here. There is a double bond between carbon number 2 and carbon number 3. Now there is no more covalent bond. Here we do not find any covalent bond. Covalent bond has broken. Is gone. Covalent bond is no more. Correct? We can see hydrogen has given its electron pair, and that's why hydrogen develops positive charge. Hydrogen develops positive charge. There is no bond between hydrogen and alpha carbon. This phenomena is known as no bond structures. There is no bond between the alpha carbon and hydrogen atoms. hydrogen does not move out from the hydrogen will not be moved out from the structure. It will remain there. Why it will remain there? Because this carbon as a group of atoms, they have negative charge, hydrogen has positive charge, and there is always attraction between a positive charge and negative charge. So hydrogen will stick to it, but there is no more covalent bond. आपको समझ में आ रहा है मैं क्या बता रहा हूं? मैंने ये बताया कि यहां से इलेक्ट्रॉन पेयर जो थी वो इस तरफ आ गई. Let me use another pen. This pen is a pointer pen only, so it will show you the points only. Electron pair यहाँ से इस तरफ आ गई. At that time, hydrogen has given electron pair here. You can see electron pair जो पहले यहाँ थी यहाँ पे आ गई. So that's why we are seeing over here a negative charge. And hydrogen has given this electron pair over here, so hydrogen has a positive charge. And earlier double bond was at this position. Now it has come to this position. This phenomenon is known as resonance, and this hydrogen it remains stuck to this particular compound because of attraction between positive and negative charge. This is known as hyperconjugation. Is this understood? Now understand one more point. We had 3 alpha hydrogen. Am I right? First time this hydrogen has given electron pair, as we can see over here. It would have been possible with this carbon. Am I right? We can see this. See here, this hydrogen has given this electron pair, and it is also possible that other hydrogen can give the electron pair. Since there are 3 alpha hydrogen, we can have hyperconjugation 3 times. We can have hyperconjugation how many times? 3 times. As many alpha hydrogens are there, that many hyperconjugation we do have. So here we are getting resonating structures. Last time we had seen if we have more than one structure, more than 2 structures, having same arrangement of nuclei but different arrangement of electrons, then the structures are known as resonance. So hyperconjugation is a special kind of resonance where between sp2 carbon and alpha carbon hydrogen, electron pair shifts in a different way. In the above resonance structure, there is no covalent bond between carbon and hydrogen. From this point of view, hyperconjugation may be regarded as no bond resonance. It is regarded as no bond resonance. Is that understood? So this is hyperconjugation where no bond resonance takes place. Let me explain further. So particularly this hyperconjugation which I had explained you. In this hyperconjugation, this is specifically between sp2, and carbon. It is between sp2 and alpha carbon. Okay. Now continue करेंगे यही point पे. Now with the help of hyperconjugation, why it does take place? It's not in our syllabus. But suppose this thing takes place, it is hyperconjugation. And on the basis of hyperconjugation, we may understand lots of things. That is in our syllabus. But before I explain you one more, explain you this point, let me explain you a very simple game. All of us we have played hide and seek. All of us we have played hide and seek. Yes or no? Now, sometimes we do experience this. In fact, all the times. Suppose we are playing hide and seek, and the places to hide, the number of places to hide. Suppose if it is less, the place we are playing, it is a small place. So, छिपने की जगह कम है. If there are less number of places to hide are there, then there are very high chances that we will get caught easily. तुरंत ही पकड़ेगा. But if the number of places are more, it's difficult to be caught. Okay, we don't get caught. Correct or not? If there are more places, okay, और जिसका टर्न आए हैं उसके तो आई को नहीं. Correct or not? Okay, वो बेचारा या बेचारी देते ही जाएगी टर्न. Okay, but similar thing happens over here. See, actually, when I was explaining you resonance, in all resonance we find electron pair shifts from one atom to the other atom. Correct or not? One atom to the other atom. And normally, reaction of any compound, particularly reaction of alkenes, is based on availability of electron to do reaction. What happens? Alkenes are electron rich species because between these two carbon atoms there is a double bond, and double bond is considered as electron rich because it has more density of electron. And normally reactivity of electron is how easily it will give away this electron to another reactant. Reactant we also call attacking reagent. Suppose there is one attacking reagent, let's say B. So alkene, how easily it will give this electron to the B on the basis of its reactivity is determined. If it gives very easily, then this particular alkene is very reactive. Why reactive? Because it can give the electron very easily to the reagent. And if it gives, okay, comparatively with lots of energy or lots of effort, then it is known as, okay, less reactive alkenes. So the stability of alkene or reactivity of alkene depends how easily it donates electron. How easily it donates electron. If I summarize this thing, if alkene donates electron easily, it's very reactive, and very reactive in another way they are called less stable. They are less stable because they give electron fast and they react fast. They are not stable. If alkene do not give electron, or rather say electron gives with difficulty, less reactive, or we can say more stable. Is that understood? Stability of alkene or reactivity of alkene depends upon donation of electron. Is that understood? Is it understood? Okay. Now I'm going to explain stability of alkene on the basis of hyperconjugation. But keeping this concept in mind, see, actually, as I was explaining you, resonance is basically delocalization of electron. As I was explaining you hide and seek, suppose this is the place where the person takes a pen, and these are the different spots where people hide. Let's say one person A, every time when his turn comes to hide, it hides only at this spot. So everyone knows about that. So whenever someone takes a gun, first of all they find out A very easily. Why? Because it is the person is sticking to a particular place. करेक्ट है ना? काफी इजीली मिल जाएगा, वो तो वहीं पे पकड़ो उसको. करेक्ट है ना? यस और नो? बट अगर ये भाई साहब ने अपनी जगह चेंज की होती बारी बारी, तो डिफिकल्ट टू बी कॉट, इजीली पकड़ा नहीं जाता. एक्चुअली रेजोनेंस तो वही है. रेजोनेंस okay is basically delocalization of electrons in different structures. Resonance, as I had explained you earlier, okay, if I talk to you about the hyperconjugation also, here double bond was taking because one time this hydrogen was giving the electron, second time this hydrogen was giving electron, third time this hydrogen was giving electron. In resonance actually electron keeps on moving to different places in different structures. In different structure, electron moves at different places. Yes or no? Okay. If electron moves at different places, then it's difficult. Okay, difficult to catch for reaction. It won't be available for reaction. So if you have more resonating structures, electron moves at more places. And electron moves at more places, it's difficult to catch that electron. And if the electron is difficult to catch, it's difficult to react. That's why it is more stable. Are you following that? What am I trying to explain? So actually यहाँ पे यही तो हो रहा है. देखिए मैं क्या बता रहा हूँ. Stability of alkenes depends number of alpha hydrogen, because number of alpha hydrogen gives you number of resonating structure. If I explain you this, last time we had 3 alpha hydrogen, so there were 3 resonating structure, because each hydrogen gives electron pair at different places. So electron pair keeps on moving. So more number of alpha hydrogen, okay, more resonating structure, and more resonating structures, electron is moving at more places. More places, difficult to be caught. So becomes more stable. Yes or no? See here, I have here 4 alkenes. How many alkenes do I have? 4. In first alkene, this is sp2. Even this is sp2 carbon. In fact, all of them they have 2 sp2 carbons. Am I correct? Each one of them they have 2 sp2 carbons. Okay, but it has 4 alpha hydrogen. 1, 2, 3, and 4. And this one has only 3 alpha hydrogen carbons. This one has only 2 alpha carbons, and this one has only 1 alpha carbon. Correct? Since it has 4 alpha carbon, each carbon has 3 hydrogen. That means total 12 alpha hydrogen. That means 12 times resonance. 12 times resonance मतलब इलेक्ट्रॉन के छिपने के लिए 12 different structures available है. So it will not react so easily. Correct or not? So this alkene is more stable. But here in this alkene we have only 3 alpha carbon, consecutively 3 into 3, 9 alpha hydrogens. Okay, so 9 structures, resonating structures. This one has 6 resonating structures because of this 6 alpha hydrogen, and it has only 3 structures. So depending upon number of alpha hydrogen and number of resonating structure, stability of alkene changes. Is that understood? Are you following? How do they ask in exam? They'll ask you, they give, arrange them, they might have been, they'll reshuffle this and they'll give the numbering. Arrange them in increasing or decreasing order of the stability or reactivity. As far as stability is concerned, this is most stable and this is least stable. As far as reactivity is concerned, this is most reactive and this is least reactive. Correct? जरूरी नहीं यही वाला थे. They may give you another structure, but you need to find out alpha carbon, alpha hydrogen, number of resonance. Number of resonance decides stability. Correct or not? Understood? Are you getting me? Okay. Here, as we move from left to right, number of alpha hydrogen is in decreasing order. So since stability of alkene is also in decreasing order, is that understood? Hyperconjugation has been understood? Yes or no? Yes? Any doubt?
No.
Yes.
Sir, can you explain it again, that alpha carbon 3 into 3 that you have given, that 9?
Okay. See here. This particular alkene has how many alpha carbons? 1, 2, and 3. And each carbon has how many hydrogens? 3 alpha. So how many total alpha hydrogens? Is that understood? Correct or not? This has only 2 alpha carbons. Each has 3 alpha hydrogens. So 2 into 3, 6 alpha. Correct or not? Is it understood? Further, any other question? Sure? Barabar check. Okay. We have understood the stability of alkenes on the basis of hyperconjugation. Yes or no? So it's an important concept. Second thing, we are going to study the stability of alkyl carbocations. What are you going to study is alkyl carbocation. But sir, carbocation कौन सी बला का नाम है? We don't know about carbocations. Let us understand that concept first. Okay. So here, before I explain you this all, let me explain you first bond fission. We know fission means breaking. Okay. In English, we use fission as synonym of breaking. Okay. Suppose bond is getting broken over here. Getting broken over here. Breaking of bond. So that is known as bond fission. Breaking of covalent bond of the compound is known as bond fission. A bond can be broken by 2 ways. Okay. One is called homolytic fission and second is called hydrolytic fission. But first of all, let us understand what is homolytic. Normally it occurs in the gas phase or a non-polar solvents. Understand that? It is a non-polar. Compound has to be a non-polar compound. And normally to do the breaking of bond, we require the catalyst or certain reagents. Let me explain it. Okay. In such a fission, free radicals are formed. I'll explain you what is free radical, but before that, let me explain you this. Suppose there is one compound called AB, and they are sharing a pair of electrons. Covalent bond has taken place. Due to some reason, this bond is broken. We don't know what is the reason. We are not interested right now to know the reason. But due to some reason, okay, due to certain conditions, that bond is broken. But in this bond, when the breaking of bond takes place, the bond pair is equally set after the fission, after the breaking. That means A takes away its own electron, B takes away its own electron, which they shared with each other. So now A has one electron, B has another electron. Similarly, in another case, chlorine, they are sharing one electron each over here. Correct or not? And due to some reason, this bond is broken. This chlorine takes away its electron, this chlorine takes away its electron. So if electrons are equally shared after the fission, then this fission is known as homolytic fission. Then it's known as homolytic fission. Is that understood? First of all, fission means breaking of bond, and if it is equally broken, then it's called homolytic fission. That's the first one I made. Any doubt over here? Okay. Second, after breaking a bond, we are saying, let's say about this chlorine. First of all, okay, when they break the bond, after breaking, it has now 7 electrons. And this chlorine also has, including this, 7 electrons, correct? It has 7 electrons. Okay, that means after breaking of homolytic fission bond, okay, we get a species whose octet is, I'm sorry, I written wrong spell over there. Correct spell should have been whose octet is incomplete. Whose octet is incomplete. Okay. That's the first point. Second thing, this chlorine has 17 proton and 17 electron. Not only this chlorine, both of them. Both of them, they have 17 proton and 17 electron. That means they are electrically neutral. That means they are electrically neutral. After homolytic fission, the species which we are getting, their octet is incomplete and they are electrically neutral. They are known as free radical. They are known as free radical. Radical means very active. Radicals mean very active. Actually, its octet is incomplete. So this species, they are going to react with someone else. They are not going to remain stable. After breaking of the bond, okay, we produce free radicals over here. Free radicals means they have incomplete octet and neutral. They are going to react with someone else. They are going to react with someone else. The species which has octet incomplete and neutral, they are called free radicals. They are called free radicals. So, okay. Here they say, in such fission, free radicals are formed. In such fissions, free radicals are formed. Another example. Okay, methane. Due to some reason, this bond is broken between carbon and hydrogen. Hydrogen takes away its electron pair. Methyl group takes away its electron pair. So here, both of them, they are known as free radicals. They are known as free radicals because their octet is incomplete and they are neutral. Since octet is incomplete, they are going to react with someone or the other. Are you following that? Any questions before I go to the next part? Anyone has any doubt? Yes? Anyone? Any girls this side? Boys? Let's continue for the next one. That was the first fission we had seen. Second fission we talk about is heterotic fission. If you do remember, I taught you in homolytic, they are supposed to be non-polar compounds. Non-polar always does homolytic. So that means polar always does heterotic. So occurs in polar solvents. Again, they need to be catalyzed by acid or base. Normally, polarity is a very great influence in this type of breaking. Let me explain you with one example. Suppose I have a compound where between these two elements there is a large amount of electronegativity differences there. That's why this bond is a polar bond. This is partially negative and this is partially positive. Correct? Due to some or the other reason. Suppose this bond is being broken. this bond, due to some reason, is getting broken. So during this breaking, this electronegative element takes up the electron pair. Are you seeing? Can you see this point over here? This group, which was more electronegative, takes the electron pair, and the bond is broken. And the bond is broken. So here, in an organic compound such as R and G, two types of ions are formed. In this, we are finding after heterolytic fission, okay, one takes away the electron pair, other is being depleted of electron pair. So one which takes away the electron pair, it forms negatively charged ion. We call them anions. The which is depleted by the depleted of electron, we call it cation. Barabar? We call it cation. Okay. Here, this R plus is known as carbonium ion. Let me explain what does mean by that. Let me give with one example. Suppose I have a compound like this. We call it chloromethane. We call it chloromethane. Okay. Due to some or the other reason. Okay. This bond is partially negative and partially positive bond. We know this. Okay. Due to some or the other reason, this polar bond is broken. When that polar bond is broken, chlorine takes up the electron pair and carbon is depleted of electron pair. Chlorine has an extra electron pair. So we are getting anion and we are getting cation. Is that understood? Are you following me? Yeah. So here carbocation contains, okay, here 3 bonding pair. Can you see that? And 1 positive charge. It has only 3 bonded pair. That means it has only 6 electrons. Its octet is incomplete. During heterolytic bond fission, we are producing R plus, which we call carbonium ion, or it is also known as carbocation ion. Means that a group of atom having carbon and positive charge. Carbon has positive charge as well as it has only 6 electrons. That means its octet is incomplete. Is that understood? So if you have a group of atoms having carbon positive charge and carbon has only 6 electrons, we call it carbocation. Is that understood? Are you following me? Let me remove all this. So we have during heterolytic fission, okay, one element takes up both the electron and that's why it becomes negatively charged, other becomes positive charge. If carbon is positive charge, we call it carbonium ion or carbocation. Similarly, it may be other way. If carbon is more electronegative and if it takes the electron pair, another is depleted. Then here we are producing carbanion. What are we producing? Let me explain with one example. Suppose if I have a compound like this. Now CHO is electronegative element. CHO is electronegative element. Normally CHO pulls electron from carbon. And in return, carbon pulls electron from hydrogen, as we have learnt in inductive effect. Okay, so when due to certain reason, if this bond is broken, then I'm sorry, here there is an hydrogen. here we have CH2. Here, during breaking of this bond, electron pair shifts to the carbon. That's why carbon has an extra electron pair. Can you see this? Or I may write other way. It's an electron pair and it develops negative charge. And it develops if you have a carbon with negative charge. Not only that, it has three bonded electron pair and one non-bonded electron pair. Total it has 8 electrons. How many electrons does it have? 8 electron pairs. Okay. 3 into 2, 6 electron bonded and 2 electron non-bonded. Non-bonded are also known as lone pair of electron. Okay, they are also known as lone pair of electrons. Yes, are you following what am I trying to explain you? So here we have a compound which has a negative charge on carbon, which carbon has total 8 electrons, 3 in the bonding form, 1 in the non-bonding form. Then they are known as carbanion. It's known as carbanion. Is it understood? Read out over here. Let me erase all this and then we will study over here. R minus is known as carbanion. Okay. Is it fine? Normally, the factor which favors hydrolysis is greater difference of electronegativity. Okay, here between these two, electronegativity difference. Negativity difference has to be high. Higher the electronegativity, hydrolytic fission becomes easier. Hydrolytic fission becomes easier. Non-detected knots, I'm going to give a print off. Don't worry, same print out I'm going to give. Is it fine? Thus, heterotic bond fission gives carbocation and carbanion as the reaction intermediate. Is it understood? Now, there are different types of carbocations. What is a carbocation? An organic species which has a carbon atom bearing 6 electrons in its outermost orbit has a positive charge called carbocation. Is it better? Now, carbocation stabilities can be explained by two effects, inductive effect and hyperconjugation. Before I move to the inductive effect, let me explain you hyperconjugation because we left that topic, we paused that topic in middle and we are doing something else. Actually, we started with the hyperconjugation.